Okay, here are the answers to the formative exam. Trigonometry, geometry, and a bit of measurement. So the first question, two solids are mathematically similar. Okay, so that's one is a scale model of the other. And we know the volumes, and we know the surface area of one of them. So we got, don't know what the solids are, but we know they're three-dimensional. Let's just presume they're kind of cubic, or cuboid. So the volume of this one is 810. The volume of this one is 240. The volume of the surface area of the larger one is 558, and I want to know the surface area of this one. Okay, so a little bit tricky here. We have to figure out what the ratio, the scale factor ratio is. The ratio of these two, the volumes, is 840 or no, 810 over 240. Okay, so let's simplify that fraction a little bit. 810, and we get 3.375 times bigger. Now we could use a fraction as well. It might be a little bit easier, I think, because we're going to end up probably getting a cube root here. So this is 81 over 24, and if we I think 3 goes into both of these anyway. I'm struggling to think of anything else. 3 goes into that, and 3 goes into 81. So we have this as our ratio. I think this is going to be easier to deal with. Why am I going to cube root it? Because, as we said before, if it's one dimension, the scale factor is just the scale factor. If it's two dimension, it's the scale factor squared. And if it's three dimensional, the scale factor is cubed, because each of those dimensions will be 3 times, or whatever, times bigger. Okay. So this is our scale factor for the volume. So the scale factor for the for lengths would be the cube root of that, 27 over 8. I know we're not looking for lengths, but the cube root of 27 is easy to get. It is 3 in the cube, so it's 3 over 2. So the lengths of each side are in the ratio 3:2. What would the areas be in? Well, that would be it squared. So 3 over 2 squared is 9 over 4. So that, finally, we've got the link between these two. A tricky question to start off with. This one is 9 over 4 times bigger, or 2.25 times bigger. Okay, so to go back, I need to divide by the scale factor, divide by 9 over 4. So 558 divided by, and I get 248. That's my new surface area. Okay, that's the answer. The first one, a very difficult question perhaps to start off with. Second question, B is due east of A. So B is due east of A. Here we got B and we got A. We know there's this angle here is 90 degrees. This whole angle here. Find the bearing of A from C. Okay, so we're looking at this angle all the way around here. Okay, I think we need to find then, if I just straighten this line out and make a right angle here, I think we need to find this angle, because it's the 180 plus that will be the bearing of from C to A. If you want to go from C to A, it's this way. Okay, so how do I find that angle? Well, I got this right angle triangle in here. I might redraw it down here. This is 35 degrees. This is 12 degrees. And I need to find this angle. Let's call it theta up here. Okay. How would I find this? I need this angle. I got this side. I have this angle. I think I just need to use 90, 35, and whatever that angle is, 180 degrees. So I subtract 90, 180, subtract the 90, subtract the 35. Don't need to use any particular ratios here yet. And you can do this on a calculator, but I think there'd be 90, 30, take away 35, which is going to be 55 degrees. So 55 degrees is this one. The whole bearing then is 180 plus that 55, So that's going to be 235 degrees. So the bearing is 235 degrees. Remember, bearing is always off true north. So we go around to this line here. So off true north and go clockwise. Okay, question 2. Calculate the area of the triangle in the previous question ABC. So look back here. I think we have this length, and this angle between. So I'm going to use half AB sine C. So half the lengths of the two lines and the angle in between it. So half AB sine C here. This formula that will give the area. My lengths are 12, 16, and sine 35. So a half 12 times 16 sine 35 gives this area. Do this in a calculator. Make sure your calculator is in degrees and not radians. Sometimes when they reset, they go into radians. So mine's back into degrees. And that's 55.1 to 3 significant figures. Okay, calculate the angle CAD. So CAD is this angle up here on my triangle, so this one. Okay, let's call it theta. I think we have to use maybe the sine rule here, because we got these. This is opposite that angle, and this 5 meters is actually opposite this angle. Let's call it alpha. I think we got to use these two to find what alpha is, and then subtract from 180 to find what theta is back here. And that's what I'll do. I'll maybe redraw this triangle on the other page. I think it's something like this. This was 5. This is 12. We got 118 across the way. So I'm going to find this angle first using the sine rule. 5 over sine alpha, I called it. So I'm looking for the wrong angle first in a way. 12 over sine 118. Okay, so quick rearrangement of that. It's going to be 5 times sine 118 divided by 12 is sine alpha. If you want to think of it as cross multiplication, you can. So 5 sine 118. Get maths for that. Divided by 12, and I get 0.367. So alpha, sine of alpha, is 0.367. That means alpha itself I can get by inversing that number. I get 21.6 degrees. So alpha is 21.6. How do I find what this one is, the one I wanted? I subtract that from 180, and also subtract 158 left, and then I also subtract 118. I think I'm left with 40.4 degrees for this. Okay, so I couldn't go at it straight away. That's why it's 4 marks, because I couldn't just get it straight away. I had to go about it 2 different ways. Calculate the length of the straight line B to D. Let's again go back to my diagram. So B to D is not drawn here. So B to D is this kind of diagonal here. Perhaps a redraw of that triangle might tidy things up. I think we have a length of 5. B to D was over here and something like this. I think 16 was here. This whole angle, well, I found 40 just a second ago and 35. So 40 and 35 together are 75.4. And we want to find this x on this side. Got that. So I redrew the triangle. If I use the cosine rule here, because I got 3 sides, 1 angle, I'll be able to find it. X squared is 5 squared plus 16 squared minus 2 times 5 times 16 cosine 75.4. So it's b squared. It doesn't matter which one way you put these around, as long as x is opposite the angle we're talking about. So this is another calculator. So 5 squared plus 16 squared minus 240 for x squared, 240.66, whatever. I'm going to square root that, so x is going to be approximately equal to 15.5. And does this make sense in my triangle? Yes, probably. Looks like the second longest side looks pretty much the same as 16. Okay, so question 3 asks us to sketch cosine x between 0 and 360. It takes a little bit of knowledge of our unit circle to do this one, and our known angles for cosine, so you can draw your table if you want, or you can draw your circle. Perhaps the circle is better. Remember, cosine, we're talking about the x-axis. So if we start here and start to move this angle around the unit circle, cosine starts at 1, because cosine's on the x-axis. So cosine starts here at 1. At 90 degrees, it is in line with 0. So we're going this way around the circle. At 90 degrees, so that is 90 degrees here, it's at 0. So at 90 degrees, 180 is halfway. 90 degrees is going to be at 0, so it goes through here. At 180 degrees, it's at minus 1. It's gone all the way down to here. Remember, cosine, you're looking at the coordinate here of the x-axis. So that's at minus 1, 0 is that point. We're not really caring about the sine value, just the cosine value with the x-axis. So at 180 degrees, it's at minus 1. And we keep going on that circle and we get to 270 degrees. So 270. And it's back. What's that point on the x-axis? That'll be 0, 1, or minus 0, minus 1. That's at 0 on the x-axis. It's back to here. And then when we finish at 360, it's back to 1. Okay. Now there are others in between these values, and you could use this table to figure it out, the sine, cos, tan table, but we just need those major values. We should have an idea what the curve looks like, and that would be it for these values. Next one is our first rotations question, or not rotation, transformations question. Reflect triangle A in the line y equal to minus 1. Where is y equal to minus 1? It is here, a line going through minus 1. Reflect the triangle A. So A, we do each point. This one's 3 boxes away, so its buddy's 3 boxes away. This one is also 3 boxes away, and this is 5 boxes away, so its buddy is 5 boxes away. And we join it. Try and use a ruler, unlike me. And it doesn't say what to call it, so we'll just call it A dash. That's the first one. Translate A by a vector minus 5, 3. Okay, so we've got to move each point in A, 5 to the left and 3 up. So minus 5, 5 to the left, 1, 2, 3, 4, 5, and 3 up. 1, 2. So there's the first one. If you know where the first one goes, you know it's the same shape. It's congruent. It hasn't changed at all. So it should be up here, I think. I'm going to just call that part B. I realize now that's part A. So I'm going to just make sure the marker knows which one's which. Describe fully the transformation that maps A onto triangle B. That looks like a rotation to me. Perhaps I have some tracing paper here, so I will draw in my triangle badly. Just start with 0, 0 as a rotation. See if I'm pretty close. And oh, it does work. 0, 0. Fantastic. Very easy. So rotation, center, 0, 0. Which way did I go? I went 90 degrees and I went anti-clockwise. Next one, fully described A to C. A to C, oh, it looks like it's got bigger going this way. So my old points are, this is 1, 4 and it's become 1, 8. So 1, 4 has gone to 1, 8. So what has happened? That means the x-axis hasn't changed and the y has stretched by 2. So it's a stretch, x-axis invariant, scale factor 2. And you could check the rest of the points, but I think it's the same. It's a bit surprised, maybe seen a pentagon, but pentagon is just 5 triangles put together. The diagram shows a regular pentagon, sides 10. One thing I'll know then is that this length is the same as this length, so it's an isosceles triangle. Find the angle AOB. AOB. So if I went around, that'd be a full circle in here at O. And in many of these triangles, what I have, and they'd all be the same length, 5. So 360 divided by 5 will give angle AOB. Perhaps you need a calculator for that. Perhaps you don't. Show that from O to A is 8.51, 3 significant figures. O to A, so that's that distance there. So we have this triangle going on. I'll put O at the top maybe. O is here. We have this triangle. I know that this length is 10. I know that these two lengths are the same. I know this angle is 72. So how am I going to find out one of these lengths? This is O to A and B. My initial thought is I got 3 sides and 1 angle. So I'm thinking cosine rule for that. So let's use the cosine rule. I'll use it as it normally is written. 10 squared is x squared plus x squared minus 2x times x cosine 72. Almost certainly is an easier way. I think the easier way is going to be actually, I will not do it that way because it will work out, but I think I'm just looking at it again that there is an easier way if I split up the angle perfectly into 36 and x here. That's much easier to just use a ratio. So I think sine of 36 is 5 over x, and x is going to be 5 divided by sine 36. This would require solving a quadratic, which I don't really want to do. So 5 divided by sine 36, 8.506, which rounds to 8.51. Okay, we did get it. My second method, first one, ignore. I could have used it, but it'll take too long. And that was what we needed to show. Find the area of the pentagon. All right, so we have 5 of these triangles now, which you could have done anyway because they told you what this length is. We have 5 of these triangles. So I want to find the area of one of these triangles. I use a half A, B, sine C. If I want to use the 5 of them, I multiply that answer by 5. So I'll do a half times 8.51 times 8.51 sine 72. So with area of a triangle form, it's always the 2 sides that sandwich the angle that we have to use. And I'll get that answer and I'll multiply it by 5 and then I'll put it in. Mess of that. So approximately 172 rounded to 3 significant figures. If you're not rounding to 3 significant figures, you probably just should get used to it. I won't take marks off you in this exam, but you should just get used to that process. Okay, so we have a pyramid question here. Looks pretty tricky. Calculate the perpendicular height of BO. We got a lot of. It's a pentagon as well. I think it's the same pentagon as we had in the last question because it's got 10 here, and the last one had 10 as well. So that was hopefully going to be useful here as well. Calculate the perpendicular height from V to O. So that means we need that length. So in the last question, we just found that length out to be 8.51. So if I have this right angle triangle, 8.51, 18 is this height, I'd be able to find the perpendicular height using Pythagoras' theorem. So 18 squared minus 8.51 squared is equal to x squared. I'm not looking for the longest side, so these are subtracted. So we get 15.9 or so. So Rio is 15.9. Calculate the volume of the pyramid. So the volume of the pyramid would be 1/3 the base times the height. So we have the height as 15.9. That's the area of the base. The area of the base we just found out in the previous question. I've forgotten what it was. Let's have a look again. It was 172. Okay. And I just typed that in. So 172 times 15.9, and then divide that answer by 3 and get 912 centimeters squared. 3 significant figures. A geometrically similar pyramid has a volume of 1500. Calculate the side length. Okay, so this one has a volume of 912. The other one has a volume of 1500. The length of the side of this one, I presume when they're talking about sides, this is the length of the side. Or is it 18 the length of the side? The side of the base, yeah, side of the base is 10. So the side of the base, if this one is 10, I need to know what the side of the base of this one is. This is back to similar question to the first one. What is the scale factor between these two? And I got a cube rooted. So scale factor of the volumes, or the ratio of the volumes, is 15 over 912. So I'll get this one as a decimal. 1.64. And I'm going to cube root this. And that will give me what to do with this one. So second, we're into math. And cube root is down here. This one. Cube root, and the answer I just got 1.18. So the scale factor is 1.18. And I'm going to multiply this to 10 by what? Definitely don't need to do this in the calculator, but again, 11.8 centimeters. So its scale factor was multiplied to get that. Okay. Next question then is a bearings question. A bit small here on the screen, but hopefully you have it in front of you. A ship sails from port A at constant speed. Motorboat sails also at constant speed. We have the bearings. Port B is, so we have this diagram here. Port B is 30 kilometers in distance south of port A. Ship leaves port A at 8:20. Motorboat leaves 10 minutes later. Motorboat, there's a lot going on here. Intercepts the ship at point C